Joint paper with Peter Ormosi, a junior colleague of mine, who's actually giving the same paper in Washington later today, I think. The other thing is to distance myself from the OFT. Down the years, I've done a lot of work, especially on impact evaluation with the office. They're not in any way responsible for the remarks I'm making here, and they may not even agree with some of them. And then finally, thanks to Paolo, he's been, apart from inviting us to this fantastic room, he was really gracious, because when I first told you the paper I was going to give, I said, well, look, Paolo, it's not really about ex post evaluation, and actually it's not really only about mergers, it's also about cartels. Now, whether or not he couldn't get a replacement at that late stage, or whether he was being gracious, I don't know. But either way, he's let me do what I'm going to do today. I'll try and obviously make it relevant to mergers. Okay. Where do I point this?
This one.
Oh, that one. Okay, starting with a joke, which my co-author convinced me was new. Apparently everybody knows this joke already. So a policeman happens upon a drunk crawling on his hands and knees under a street lamp on a darkened stretch of pavement. When he inquires, the drunk explains that he's searching for his lost keys. The policeman promptly kneels down, so this is England, not the States. The policeman promptly kneels down and begins searching as well. After they've scoured the nearby pavement and gutter several times over, the policeman thinks to ask, are you sure this is where you've lost your keys? The drunk replies, oh no, I lost my keys about 50 yards, i.e. meters, back there. He gestures at the darkened street behind him. Well, then why are you searching here? Asked the policeman. And the man replies, well, the light is so much clearer here. Now, metaphors are always dangerous, and I'm not meaning this literally, and I'm not implying for 1 minute that competition authorities are drunk. It's just an amusing way to start. Okay. So what am I going to be talking about? As you all know, evaluations now increasingly frequent across the world. For example, in their annual impact evaluations, competition authorities ask, do our policy generate benefits which are greater than the costs that we incur? And I've been responsible for some of that, and I'm not in any way devaluing it. But nearly all evaluation of that sort is based only on cases that we detect and that we intervene as competition authorities. And of course, it is only, to use another cliche, only the tip of an iceberg. And one is bound to ask, what about all the deterred cases, which after all is the main purpose of any law, to deter? But having thought about that, what are about the deterred cases, which of course we never observe? What about another set of cases which we never observe, which are the undetected cases, which you might consider to be the failures of competition authorities? So that's the first thought. The second thought is, what, moreover, if those cases that we don't observe, for one of those two very different reasons, what if they're much more harmful than the cases that we do observe, what you might call the sample selection problem? And that's endemic, not just in this area, but if anybody who's ever written a paper for an academic journal which uses data based on cases prosecuted and reported by competition authorities, anybody who does an empirical study on that sort of data, the first, very cheap, but nevertheless relevant comment you will always get from a referee, especially if he's lazy and doesn't really want to do his job, what about sample selection bias? I promise you that's true. So it's an endemic question. And the purpose of this paper, which as you'll see is very, very speculative, it's very much a first blush. In fact, I don't even think really we have a paper yet. Pete was pushing, my co-author, to bring it out as a discussion paper, so it is, but I think it's still very embryonic. What we want to do in this paper is to marshal what we do know from theory and from deductive logic about what we don't know, what is unknown, deterrence and non-detection, in order to make informed speculations about the direction of bias, but also the magnitude of the bias. Now, that was the initial purpose of the paper, but then I started thinking, well, if we can do that, at least conceptually, then that does actually edge us towards two much more ambitious questions, which I think, in fact, are impossible questions, but that's what academics are supposed to do. They're supposed to ask impossible questions and then try to answer them. The first of which is, how much potential anti-competitive harm is there out there in an economy? The minute I thought about that, I thought, oh, blimey, Harburg in 1954. And I doubt there is a single person in the room apart from me who will know what Harburg in 1954 was, maybe someday. And it was this paper which, if I can use the vernacular, English vernacular, pissed me off when I read it, because it told me that competition policy basically saved, I think, or, I know, was it saved, or there was harm out there in the economy which amounted to 0.1% of GDP. Not very much, in other words. Now, if you take that seriously, what are we all doing here? Is this really a question that an area we ought to be researching in? So that's question one. How much conceptually harm is there out there in an economy? And then question two, how much of that harm is a competition authority successful in preventing? Not just in detecting, but in deterring. So those are the big questions. Now, there's really good literature, which I haven't got time to talk about here. As you'll see as I go through my slides, a lot of them are about cartels, which I'll drift over. But let me stop at surveys of practitioners towards the end. This is largely OFT, but the Dutch authority, as was NMA. And they've carried out surveys asking practitioners how many cartels or mergers are deterred, and for that matter, detected. And summarizing, rather over-summarizing, the message you get there from those sort of surveys is that for every blocked or remedied merger, there are another 5 which are deterred. And for every busted cartel, there's another 5 which are deterred. Now, I don't want to get hung up on those numbers, but because that's not the purpose of this talk. But I'm going to take those as stylized facts as I go through. So that's one piece of stuff we're taking from the existing literature. The other is the impact evaluations by competition authorities. I've listed some of those who are doing it, do these things, and many others may now follow suit. Certainly the OECD, I think, is trying to nudge them to do so. Typically, in an impact evaluation, and it varies between authorities, of course, the competition authority evaluates ideally all cartels, anti-competitive mergers, and abuses in which it has intervened in the year. And making very conservative assumptions, it assesses the consumer benefits that emanate from its interventions. If you then compare those with the costs of the competition authority, benefits are calculated in the way I've just described, are typically pretty impressive. For example, in the OFT over a number of years, on average, they're about 10 to 1. For every pound the OFT spends, it calculates using very conservative estimates that it's saving consumers £10 in terms of avoided anti-competitive behaviour. But those estimates quite deliberately make no allowance for deterrence, or for that matter, which the office acknowledges and other authorities acknowledge, that there is a deterrence factor which is not being quantified. What they don't so often mention is there's also presumably a lot of undetected harm out there which they haven't been able to discover. So, in pursuing that rather ambitious objective, let's have a very simple model. There's not very much maths in this paper, I can assure the lawyers. So this is a thought experiment. Suppose you've got an economy where there are n potential cases, of anti-competitive harm. You can run this for cartels, anti-competitive harm, anti-competitive mergers, that should say, sorry, or abuses of dominance, and introduce 2 simple parameters. Omega is the probability that a case is deterred, and sigma is the conditional probability that if a case is detected, given that it's not deterred. And let's assume for the moment, although I'll come back to this later and make it much more relevant to mergers, this is general for the moment, assume that all detected cases are in fact prohibited or remedied. So for the moment I'm assuming, well, type 1 and 2 errors I'll come back to later. So the number of detected cases and the number of cases, if you like, which are reported on in the impact evaluation is C, and it's 1 minus omega times sigma times n. What about some first blush estimates of what that might look like? Well, using information from the above surveys, and you can substitute any other number for omega and sigma if you prefer, you can easily back out what that implies for omega and sigma. I'll mention mergers. Omega is 0.83. Most cases are deterred, according to the OFT and the NMA. For the moment, I'm just going to assume that detection of mergers, anti-competitive mergers, is certain. I mean, we can modify that if you like, and I think much of the interesting story on mergers is not to do with detection, it's to do with business chilling or force intervention or deterrence. But assuming you take those parameters as okay, then you can back out, if you know what C is, the number of cases that the authority is reporting, it's intervened in, it's pretty easy to back out N, the number of potential cases in the population. For cartels, it's 11 times C, 1 of which is detected, 5 of which are deterred, 5 are undetected. For mergers, rather boringly, 1 is detected. For every 1 detected, there's another 5 deterred. So that leads to the obvious proposition, which is hardly very surprising. Detected cases are likely to be only a small proportion of the population. Remember, I'm talking about a population of potential cases. But we can go a bit further than that if you want. Rather than just think about the number of cases, and this is really the purpose of this paper, we can start thinking about the magnitudes of harm involved. Now, again, it's very easy to use those sorts of multipliers that I just mentioned to back out estimates of deterred and undetected harm. Because if we take the European Commission DG Comp, now I'm using them purely as an illustrative example. This has nothing to do with the DG Comp. I would have used OFT, only I'm a bit too close to them. So if you take 2010, in that year, DG Comp reckoned that its anti-cartel activity saved European consumers 7.2 billion euros, and its action against anti-competitive mergers saved them 5 billion euros. Well, bearing in mind those multipliers that I just described a few minutes ago, you can simply multiply those numbers by those multipliers, and you get the value of deterrence as being 25 billion euro for mergers, 36 billion euro for cartels. On the other hand, undetected harm from cartels is also 36 billion. But, and this is really where the paper starts, so I think those initial ballpark figures are quite interesting. But this is where the paper starts. Why should, this is the question we're asking, why should cases which are detected and intervened by the competition authority necessarily be representative of the cases either that it deters or the cases that it fails to detect? And that's the question that drives the paper. And as I said, that sort of issue is endemic in a lot of IO research, but if you need that underlining, sorry that this is cartels, but one of the things that we teach our students is the typical cartel has 7 members, that's median. Typical cartel lasts 7 years, median. Typical cartel, according to John Connor, overcharges some amount, let's say 15 to 20%, conventional wisdoms. But of course, those are all based only on cartels that we detect. And they don't take any allowance, make any allowance for the cartels that we've deterred. And probably the way that I've set it up, you'll know what's coming next. The way that we've approached moving the question, and Paolo, you really must keep me on, because this is a rambling academic piece which could go on for 2 hours if you want me to. But it's lunch.
I give you the first time.
Okay. Well, the way that we've approached this is to think of it as a very simple sample selection problem. So here you have to do the thought experiment, for not being patronizing for the lawyers. Imagine you've got this population of cases out there, which are potential cases. That's the population in a statistical sense. And then we're taking a sample from that population. The sample that we're taking are the cases which are not deterred and detected, but out there's the rest of the population which is maybe deterred or it may be undetected. And if we're going to use the sample that we do observe to make inferences about the population which we don't observe, we need to know basically 2 things. We need to know something about the form of the population from which it's drawn, and then secondly, we need to know how the probability of case selection varies, whether it's omega, deterrence or undeterrence, and sigma, detected or non-detected, how they vary with harm. 10, that's fine. Well, what we do in the paper is to basically survey some fairly wide-ranging academic theoretical literatures on mergers and cartels, and then we try to draw inferences about both of those things. And to keep things simple, we're going to simply distinguish a trichotomy between low, middle, high harm cases. So we're not talking about continuous relationships here. So the one graph in the presentation, the population distribution, we posit, will be positively skewed of this form. It may not have a mode, it may be monotonically declining. The main point there is that the potentially high harm cases may be very, very harmful. Okay? So it's just one thought to carry with you, that the top tail of any skewed distribution like this is inevitably going to have an average harm which is much higher than the lower tail. Now, I've drawn that as a positively skewed non-negative distribution because remember, I've defined the population in the first place as only those harmful cases. There are, of course, mergers which are not harmful, but that's not what we're talking about here. Okay, well, what can we deduce from theory? Cartels there, sort of literature. I'll leave it on the screen long enough for you to see the sort of literature we're surveying. Mergers, for the moment, we're going to assume that detection is 100%, at least above some threshold harm, and that below the threshold that the authorities use, harm may exist, but it's pretty trivial. But on mergers, the line I want to concentrate on here is the omegas, which basically says that deterrence is probably going to be high for undetected small harm cases. Why? Well, because if it's a case which is harmful, but nevertheless not that profitable and harmful, then probably the fixed administrative costs of getting involved in merger proposal, taking it to the authority, paying lawyers an awful lot of money, probably those costs are going to deter you from even pushing forward those rather minor harm cases. On the other hand, at the top end, in the high tail, we argue that the deterrence there of really harmful cases will be virtually 100%. Why? That may sound dramatic, but then ask the question, how many mergers do we actually observe, which would be the mergers which are most privately profitable, which typically are mergers from duopoly to monopoly? I know there are some, but not many. Why don't we observe them? Because they don't happen. Why don't they happen? Because firms wouldn't bother bringing a merger to monopoly to an antitrust authority unless they've got some excuse of failing firm or something like that. And there's some quite nice literature which I could refer to there, some of which is Tommaso. Now what we do on this slide, which I'm going to skim over, but basically from a sampling problem of the sort that I've just described, it's possible to work out what an estimate of the harm caused by the population is from the harm from the sample, that's H superscript S, and lambda, which is the proportion of cases that you think that you're observing. And typically it's a messy form, which I won't dwell on in this forum, but it enables us to quantify, at least conceptually, where the biases will lie. And that leads us to two propositions. With random sampling, if in fact you think the cases that we observe and detect as an authority are a random sample of the population, then the simple multiplier, the sort of thing I was talking about earlier, is of course an unbiased estimator. But the minute you introduce differential sampling across segments, in other words, contemplate the possibility that deterrence varies systematically with the case harm, and that detection does, then the estimator immediately becomes biased. And then essentially what this algebra shows is that the direction and magnitude of the bias depends on two things. One is the sampling differentials, and the other is the relative size of mass in the two tails of the distribution. Second proposition, and this is a really nerdy point, which I doubt whether anybody in the room will know what a symmetric Lorentz curve is, but there is a certain class of positively skewed distribution, which includes the log normal, which is one of my favorites, which does generate what is known as symmetric Lorentz curves. Now, if you're talking about a population distribution which has a symmetric Lorentz curve, that formula simplifies rather nicely, and basically you can show that the bias will, that the simple estimator that I talked about earlier will be upward biased if the upper tail is more heavily sampled than the lower tail, simple point, and that the magnitude of the bias will be greater the more asymmetric the population size distribution is. Now that's clearly a special case because the log normal, although a usually pretty good approximation, is just that. But it's a good way of concentrating one's mind. Two things that really matter. How asymmetric is that distribution that I had on the screen earlier? And what is the tendency to oversample in the high tail or the low tail and to detect or undetect in the low tail? Yeah, no, I'm fine, thanks. Now, if we apply that sort of methodology, that sort of sampling, simple sampling analysis to the present case, it is possible with the two things that I mentioned earlier, that the primitive estimates of omega and sigma, and on the one hand, and an estimate of what is the sample harm that the authority claims to detect, it is pretty easy to back out in a couple of stages. An estimate, first of all, of the aggregate population harm, second of all, the undeterred aggregate harm, and then thirdly, by deduction, you can estimate the deterred harm and the undetected harms. And what we're doing here is using it as a purely illustrative simulation. The two of us, me and Peter, have often argued about whether we should have any numbers in here at all, but we decided to because it concentrates people's minds. So these are the omegas and sigmas that I was talking about earlier from practitioner samples and from the academic literature. We take a base case scenario with a log normal with a lower tail, which is 40% of cases, accounting for 5% of harm, which in terms of the underlying log normal that generates it is 1.39, which for reasons I haven't got time to go into is, I think, plausible. And then we use different scenarios about what the sampling differentials are between high, medium, and low cases. And we apply both the log normal, which does have that mode, as I had in the previous graph, but the Pareto curve, which does not. But they're both positively skewed. Those are the baseline assumptions for omega and sigma, how they vary across cases, consistent with the aggregate estimate. And these are our simulations. Oh, cartels you don't want to know about. Can I?
Yeah.
Okay. I think the story is more interesting for cartels at the minute. No, actually, basically, the bold at the far right is what the simple biased estimators would give you. We detect 7 billion. In fact, the population is 79 billion. But if you start playing around with different assumptions about the sampling differentials, particularly assuming that we don't tend to sample cases in the top tail because of deterrence and undetection, then you can get much bigger numbers going as high. And also, what I'm doing in those simulations is varying the degree of asymmetry in the underlying population distribution. So it's those two key things that we're playing around with. And you can see that the population harm could be as much as 181 million, which is obviously a lot more than 7, most of which, half of which is undetected. On mergers, it's a bit more boring at the moment because basically all we've got to estimate there is the amount of deterred harm. The unbiased estimates would suggest that it's about 24 billion. The biased so that's the biased estimates. The unbiased estimates, depending on asymmetry, could be as much as 42. Now, so far I've abstracted from type 1 and type 2 errors, which I don't think are an issue really for cartels, but for mergers they clearly are. Type 1, what are we talking about there? Deterring pro-competitive mergers, business chilling. Well, of course, there we've abstracted by looking only at the population of harmful cases in the first place. But our intuition here is very much the same as we had for small harm cases. In any case where the profitability of the merger is relatively small, then it may well be deterred. Now, if that's relatively small because it's anti-competitive, we're pleased. If it's relatively small because it's pro-competitive, business chilling, we're unhappy. But the other side of that coin is the assertion, but I believe this is a reasonable one, that any quite obviously very, very privately profitable but also socially profitable merger will rarely get deterred. It doesn't make sense. Now, if you buy that story, we can put a ballpark figure on the business chilling, which is basically, it's just the mirror image of the harm which is deterred in these relatively small anti-competitive mergers, and it comes out at somewhere between 1.5 and 3.5 billion euro. On the intervention side, it's rather more interesting. Now, here we redefine the original framework. So now we talk about the number of observed cases, 1 minus omega sigma, but now we've introduced theta, where theta is the probability of intervention, given that this is a harmful case, and 1 minus theta is clearly a type 2 error. We need to, if we want to factor that into this analysis, we need to know two things. One is the overall probability of type 2 error, and maybe Tommaso might be able to give us a number on that. But perhaps more interestingly, how that varies with case harm. But just to give you an idea of how it works, assume it's invariant with harm and that it's a probability of about 0.1. Then the true harm of detected cases is 5.6 rather than 5, of which the CA fails to recognize that 0.6 is due to type 2 error. I'm sorry, I've had to skate over that because I know I'm running out of time. Conclusion, well, how much harm is there out there? If you believe this story that I'm giving you here, it's a lot. In this illustration, it's between 109 and 266 billion euro, of which only 12 billion are detective. Sean Ennis, I gave this paper a quick trial in our own conference a couple of weeks ago, said to me, do you realise, Steve, that that's, I can't remember what percentage of European GDP was. I think it was 2%. Do you remember, Tommaso? Anyway, a lot more than Harburger's 0.1%. So I've achieved one thing with this paper. So that's one question. There could be a lot. If you buy the story, and of course you can play around, it's very easy to play around with alternative parameterizations. Second question, how successful is the competition authority in combating that harm? Well, on the one hand, we've got to take into account deterrence as well as direct interventions. And the answer there is, well, about half, roughly half for cartels. And the other half, it doesn't because it doesn't detect them. For mergers, all the harm by assumption is avoided, but type 1 and type 2 errors, according to the back of envelope sums I did in the last couple of slides, might be costing us 4 billion. Of course, this is ridiculously speculative. These are impossible questions. It's really an issue of, well, what do I think the future agenda is? I think the main purpose of this paper is not to push numbers like that, which get people's attention, especially just before lunch. But it's really to set an agenda of things I think we need to be looking at in the future. And I think for sure we need a better understanding of the population, and that includes the population of mergers, and that resonates with some stuff you've been talking about. And I think we also need to know something about, a bit more than we do, rather than just casually taking the odd prediction out of very good theory, to know a little bit more about how, well, a lot more about how deterrence and detection might vary with case harm. What sort of methods might we use? Well, here, so far, we've largely just drawn on existing theory, sometimes brought out implications that the authors didn't stress themselves. And I think the way forward, well, I hate to say it as being a non-experimentalist up until the last few weeks, but I think experimental work might be mildly helpful on deterrence. But I'm much more comfortable with empirical analysis, and the one thing that I started to do in the last couple of months is to look at historical data, which it is actually possible to look at cartel data for jurisdictions under which cartels were not illegal, and to compare overcharges with jurisdictions where they were illegal. Now here I've used John Connor's database for the moment, not cleaned in the way that everybody tells him he should have cleaned it. But that's quite interesting, because what you find when you compare the two distributions, cartels which were illegal and ones which were under jurisdictions where it was not illegal, you find the mean is more or less the same, mean harm. And that's the point that John himself brings out in some of the papers, usually en passant. But what you do find, and this is what I found really interesting, is that the tails, the lower and the upper tails of the distribution, are much more sparsely populated in jurisdictions where cartels are illegal. Now, I interpret that as broadly consistent with what I've just said to you, because what that implies is that we don't observe as many low-harm cartels in jurisdictions where cartels are illegal, but also we don't observe as many high-harm cases. Why? Well, maybe they're deterred, maybe they're not detected, I don't know. And the other thing, I think, is some sort of meta-analysis of price-raising effects of mergers. Lots of things. And as I say, please don't take me to be some cranky guy who's saying these numbers are what I believe. They're just a way of concentrating one's mind. That's it.